subsurface, although ancient Martian surface environments could potentially, harness life. Um, which brings up your atmospheric like influence on the entire situation. Um, Basically, it's assumed that Mars used to have a thicker atmosphere, which kind of be more conducive to life. But around the time of the late heavy bombardment, the planet began to lose its atmosphere, and this progressive decline actually occurred relatively fast geologically, um, with model-based calculations suggesting that the atmosphere was lost within about 500 million years or even less. So that really kind of switched things.
Let's see. So obviously we're looking for ancient surfaces that might be able to preserve evidence of life. Basically, and then we go to where you want to look. So we talked about like hydrothermal springs that we kind of think that that's a good analog on Earth. That's where we think life probably originated was the deep sea vents and hydrothermal springs. So obviously there's subaerial hydrothermal springs, which are on the surface, and you've seen it like Yellowstone and stuff. They have the algal mats that are really colorful. So those are extreme environments that like still harness. They could, if Mars is still, warming, you can still have hydrothermal activity. And then we have subaqueous thermal springs, or four, which obviously they're not on the surface anymore because there's no water on the surface. But they could be subsurface and subaqueous thermal springs. And those obviously, those are going to be deep in the cryosphere. Talk about, obviously you're looking at subsurface, any sort of subsurface water systems, but they're subsurface, so they're kind of hard to find and identify. Paleo lake basins, obviously that's a great place. It's where water once was, and then you get a lot of, carbonates being deposited in lakes, and you get shales and some deposited in lakes. And we talked about, the evaporites and the detrital sediments being a great way to preserve life.
Not,
So,
not to mention the fact that paleo lake basins are kind of ideal landing sites for future missions.
mm-hmm.
This, this was before Tess and Themis data. Have we found any
Well,
carbonates or anything like that in
yes.
these paleo lake basins?
I think that
Carbonates?
I'm not sure, but
Shales?
I'm pretty sure that they have found carbonate outcrops. What they think are carbonate outcrops based on Tess and Themis.
Okay.
Yeah, if
I
you
don't
look,
remember
I'm not
reading
sure though,
anything
but I
about
mean,
any
even
of
this, they said there are, several places where they pretty much positively identified paleo lake basins. So then it's kind of only assumed that there's going to be lake sediments in there, whether they be carbonate or, detrital.
Okay.
So those would be great places to look.
and also with the coastal environment, you have present fine grained material that would help in preservation as well, in the form of shales and marls, which figure 5 and 6 both show like kind of your lake environment on Earth in terms of what you would expect. Figure 5A shows the tufas that I talked about in this paper, um, just in terms of like carbonate settings, I guess. And then A of figure 6 kind of looks closer at it. And just one of the things about carbonate preservation is that you can save a lot of microbial life, stromatolites, any other sort of microfossil.
With like the whole evaporate thing, there's been a lot of research about, preservation of microbial life in evaporites. And they're talking about how there's lots of studies been done that show as evaporite crystals, the crystalline structure forms, it can trap pockets of still liquid water in it, and obviously whatever's in the water, so microbes. So you still you have a a tiny little enclosed environment for life to continue. So it's like they can survive, they can continue like living and reproducing for several years in the structure itself, the crystalline structure. And they said like the preservation for that, obviously like there's no in or out, it's a closed system. They said the preservation for for the microbes inside these crystals is could be millions of years. So it made a great place to look if you find evaporites to, really get down and analyze them and see if you can find a pocket, see if there's anything inside the pocket.
So we'll move on to the whole duracrust hardpan soil thing. If you're not really familiar with duracrust, it's basically the layer that's created when um, surface water leaches out soluble minerals and redeposits them deeper. I kind of, I think, I don't know if these two terms are synonymous or if subsoil hardpans are, the path that they travel. But I know that just that's the general idea is that you have a lot of leaching going on and it's bringing different chemical constituents deeper, which could be a potential regions for life on Mars.
And to answer your question, yes, there's paper identification of carbonate-rich outcrops on Mars by the Spirit rover. So
How many hills and gooseholes are here?
Alright, we just never talked about it in class.
there's our answer right there. It'd be a great place to swing your rocket on. Some samples.
You first.
If only. Dude, I'll totally go. If they ask me, hey Johnson, you gonna go to Mars? I'm like, yeah.
Like, yes, sir.
You're not coming back. You're like, you know what? I'm alright with that. Totally be alright with that. Yeah, so then the last place they kind of talk about looking is in subsurface ground ice. Obviously, talk about any microbes, any sort of life can be same way with the evaporites. It can be incorporated into the structure, into the crystalline structure of the ice, and then preserved for an extremely long amount of time. Or the same deal. There might just be like a pocket of liquid water in the frozen crystals that's high enough pressure to keep it liquid, so it can be a closed system where life can thrive. There's a lot of places that you can look. You just have to find those places.
So, are you done?
Almost.
Okay.
So
Are you done?
I was gonna get into something, but go ahead.
essentially, this paper just kind of summarizes that the most favorable host rocks are those made up of densely structured, stable minerals like silica and phosphate. These lithologies, along with fine-grained clay-rich detrital sediments and carbonates, harbor the most of the fossil record on Earth. So that's kind of where we would look on Mars.
Obviously, the huge problem with identifying these places to look is our resolution. We need better resolution to be able to find, a tiny outcrop that's, silica rich or phosphate rich, or it's made out of carbonates or something. We need to find these locations to be able to search them in the future.
More resolution.
That's just always the problem. Better resolution. So, Adam, you wanted to bring something up?
I wanna play a game, since we got some time left. You guys wanna play a game?
Is this a fun game?
No, but it's a game.
Okay.
So,
Alright, let's try.
we're a team tasked to send a rover to Mars and search for life.
Did Keith tell you to send it?
No.
Okay.
I came up with the song on my own. Where are we going and why?
Well, that depends what we're going there with.
Well, we can start there.
I mean, because the equipment that we're bringing in is gonna dictate our abilities to Okay, here's what we're gonna do. We're gonna land in a central location. Just your basic lander. And it's gonna open up. And all of these, like, bumblebee-sized
For once in Star Wars again.
what
Probes.
do you wanna call them?
Probes.
Small around multi-purpose machines are gonna come out. Yeah, nanobots. They're real little. They can fly very well.
Do a bunch of science.
And they pretty much navigate themselves.
That
They
would be ideal.
have set
So
locations.
now we're talking
We have
about
points.
artificial intelligence.
We have points set across the whole globe, and each of them is programmed to go to its location and
Based on GPS?
conduct. I don't know about GPS. Yeah, I guess.
Would we have to put GPS satellites up
We have
first?
enough
Yeah.
satellites
Yeah.
that they can position themselves.
Well, that's why I'm thinking they could use the ones that are already there.
Probably.
Now I'm gonna go to their locations, and each is gonna perform a series of tests
So what test?
and send the data back in real time.
Spectrographic analysis, chemical analysis.
Some of the efflorescence, I like that stuff.
Did you fit that in a little baby bumblebee?
Yeah,
In the
because this is
future,
my
anything is
imaginary
possible.
this is my imaginary mission to Mars.
Okay.
I think you had them on specific reasons.
Well,
It's kind of what I was
mean,
getting
there's
at.
like 150 bees, so
Got it all. Alright, so
It's not
we're
in the
plotting
story,
it.
we're
We're gonna
done.
do like a full survey, but then it gets better. After they send back
And then
this
terraform
like
Mars, right?
remote data, then they burrow. I saw some of those burrowing bees, those mud bees. I've never seen those by Strout's Run Lake.
Carpenter
Yeah.
bees.
Is that what they are? Carpenter bees? It's the weirdest thing.
When you're standing there and they come up and sting on the bottom.
Well, they didn't sting me,
They
but I
don't
watched
sting.
them for quite a while. They were pretty
Get some of
interesting.
those.
It'll be like that, but they'll be machines, and they're gonna burrow, and then to different depths. No, let's do it all the same, because then we can get one like subsurface layer. High into the geoid, and then they're gonna bring those samples back.
Okay.
Alright, well, let's say we're not like
They're
400
like
years in the
radio-
future.
So we're
They're
just sending-
radioactively powered, so we don't even have to worry about fuel.
Let's just say this, we're sending Curiosity. Where are we gonna send the Curiosity rover?
Yeah, where would you send one? One
Well,
rover, you get one. And it has
I-
to look on the surface only.
I mean, we've kind of gotten bored, not so much bored, just like frustrated with the surface. So I mean, we're all kind of thinking deeper, right? I mean,
You can get deeper on the surface.
I understand that. I'm just saying maybe like a large basin such as Hellas. You know, if we have better drilling capabilities in search of these chemical signatures of life, I think that would be good. Because I mean, I read a bit about how impacts kind of exhume a lot of material and expose some of these layers that we're investigating. So that's my vote. Hellas.
I think we'd be better off. It's completely unrealistic, but
Oh really?
unlike the bee idea,
Bees.
in the highlands, because I mean we always land in flat, smooth areas for obvious reasons, but nonetheless, we don't have much surface area or much surface data.
Yeah, I
In
don't
the
even
highlands.
In like a crater.
Well, I'd almost rather not land in a crater. I mean, it makes the logistics make sense that we would.
You can get more subsurface data
Right.
that way.
They couldn't even land in Hellas, I don't think, because of the
But it's been altered so much, and that's where we land in craters because they're flat and smooth and it's safe to land there. So if we're gonna imagine where we want to land or where we want to get information from, I think that there's more information in the highlands than there are in crater floors.
What if I meet you halfway and give you back